All right, everybody, I'm going to get started here, so if you can all quiet down, thank you. No, I'm not that much of a jerk. So my name is Robert Rowley. I'm going to be talking about the state of web application security. The title for this talk is supposed to be actually Max Web Security. I unfortunately forgot to change my slides. Basically, this is a synopsis of a lot of the web application security stuff that I've seen where I work, DreamHost. Who here has heard of DreamHost? Like a third of you. Probably more of you know, but yeah, we're a fairly large shared web hosting environment, which hosts somewhere upwards of 1 million domains. I'm not trying to pimp the service. It's just simply the fact that we have a lot of sites hosted, which gives us a key and unique insight on the web-based attacks and web-based malware, things that are going on with web application security. There's my contact information. I'm going to have it again later, so if you want to harass me. So the breakdown of this talk is pretty easy. I'm going to go over some basic trends, tell you basically what we're seeing, as I mentioned, how we're and what we're tracking, cool stuff that's going on, as well as knowing a little bit more about what the attacker's motivation factors are, because that's key to know. If you want to be able to stop somebody from what they're doing, you have to know why they're doing it, and you can cut them off at the source. As well as then, when we have time, which we probably will, I'll go into a lot of auditing, backdoors, as well as release some of the basically, not really source code, but the tools and the source of how to clean up your site if it's been hacked. A lot of the utilities that I use on a day-to-day basis that can do very complex and very powerful things with. You'll probably be surprised that I'm going to do this. You'll probably be surprised about how easy it is. So, yeah, I'm going to just kiss the mic now. I have to do this every time. So, without further ado, I'm going to go into some trends. The data that's collected with these graphs that I'm going to show you and how we identify these trends is all logs that are generated using our web application firewall, which we ended up using as Mod Security, which is an Apache plugin. It's running on about 1 million or more websites, which again gives you a large sample set. The logs for the system are actually all centrally logged across all 20 to 30,000 of our servers. They all get pulled to a central location, and that's where I basically do some analytics and review about what's going on, dig in further into what the attackers are doing, motivations, etc., so forth. So the data set is actually 26 million records. It generates about, right now it's generating about 3 to 5 million per month. This is about a year worth of data. And let's just get into this graph. So I have to explain. Graphs kind of suck. I'm sorry. This is a day-to-day graph of the total number of attacks based on some key common attacks that we see on our network. You can see that it averages around 50,000, 55,000 this line. So about 50,000 would be right about here. 40,000 would be right about here. So 40 to 50,000. This is between August 22nd and March, I believe. Unfortunately, like this graph, I didn't extend it along. Well, this is the average per day attack. And I'll do a quick breakdown of some generic complexities, or basically generic types of attacks. The red here at the top, this is a percentage now, stacked line graph. But the red here at the top is a file upload based type of attack. The green is SQL injection. The yellow mass majority is local file inclusion as well as remote file inclusion attempts. These are fairly common. You've probably all seen these in your website access logs. If somebody just put a variable as .. / etc password. It's like I don't know who's doing that still. I don't think they're ever successful, but it's like constant. And then the bottom here is code execution attacks. These are if some PHP code or some other like a web-based script is so badly written that you can just do a direct call to PHP or a code execution in your attack. So these next graphs, what I'm going to show is some very specific attacks against specific software vulnerabilities. Exactly. This isn't an attempt to knock on E107, which is a content management system, nor Zencart. It's just simply these are good examples that I have the data for, and they're very old exploits. So they've been well since patched. The first one is an example of a remote code execution. This was very unfortunate for E107 to have because it was a very powerful attack for the attacker's point of view. The vulnerability was pretty much exactly this. You tell one of the variables in the GET request to be PHP and BB code, which was just put square brackets around PHP, and then you can type in any PHP code after that. And the server, the E107 content management system, would happily execute that PHP code. So the entire attack existed only right here. This was released in May 2010. The CVE code is right there if you want to look into it some more. And then the other one that I'm going to go into is Zencart. Zencart's a very popular web, like open source web shopping cart. The attack here was released in May 2009. There's CVE code. It was actually SQL injection / execution. I'm not going to go into the details on it here as in comparison to E107 because it's complex. But so these two attacks, even in 2011, which is when this graph starts in August 2011, goes on to May or March 2012. The average attacks are still around 10,000 per day per each one of these known exploits. And then now these exploits are 2-3 years old, and they're still attempted to be compromised every single day. You can also notice that they're very similar number of attacks per day for two very different types of compromises, or very different exploits. So this I can identify as pretty much a good steady trend of this is the background noise about what a baseline for new vulnerabilities or exploits will get you on attacks per day on our network on any given day, even years later. Now I'm going to add a little bit more, something more interesting is that Tim Thumb. Who here has heard about the Tim Thumb vulnerability? Who here was affected by it? Sorry. So Tim Thumb vulnerability was, again, I'm not knocking on Tim Thumb. It's not anything intention. It's just a good example, and I have good data to show you. The vulnerability here was released in August 2011, basically when these graphs started. There's a CVE code. It basically allowed arbitrary file upload. The script is a thumbnail generator script, which you can give it a URL, and it will basically download a copy of that image and then resize it for your blog. The problem is when it downloaded a copy of it, it didn't change the extension. So it always presumed .jpeg should end with .jpeg. And it uploaded it to your cache directory. It kept the same file, and it was just called the whatever .jpeg. Problem is, you could tell it to go download some PHP code, and it automatically downloads that PHP code and uploads it to your site's cache directory and keeps it .php. So then you just turn around and go into the cache directory and call that file name that you just told it to download for you with .php, and it will basically happily run as PHP script. This is a popular WordPress theme component, which was pretty much the reason why it became so popular and was so impactful when it happened. And I should note that this was not part of WordPress core, nor was it a plugin. This was simply something that was added to a lot of very popular WordPress themes, not the core themes either. It was just very common to have people add in because it was easy for these developers to add this code in, which did this thumb resizing for them. Unfortunately, there was vulnerability, it was insecure, and it was also very difficult to explain to people, your WordPress is up to date, but your theme over here that you're not even using has a script in it that's being compromised up to no end. So just get rid of it or do something. So here's that same graph before. I shrink it down so I can fit some more data. And this is actually between August and June, end of June this year. So there's Tim Thumb's effect. In the beginning of August, there's a little spike right here. A short while later, about 2 months later, there's that major spike, and that's really where a majority of the action happened. If you were compromised by a Tim Thumb vulnerability, you likely were compromised in November, or you noticed it in November. What's interesting is there's that 2-month gap where it kind of dropped down and disappeared. And then onward, even towards this end of the year, it's still getting... It almost evened out with the other types of attacks, but then it's still getting a very good, solid, actually double or triple times the normal attacks that we're seeing. This is how I show what I call the life cycle of an exploit in the wild. The initial, basically the initial phase of the infancy, there's going to be a spike. There's people searching, checking to see how many hosts are affected. And then there's the puberty. The puberty stage is when shit goes insane. This was getting 70,000 hits on basically all through November. It was getting between 50, spikes between 50 and 70,000 per day. That's just one day of attacks. And that's when it's going to get the worst. That's when it's going to infect the most number of hosts. And then from there on out, it's kind of the maturity level where it just kind of rolls on out like this man getting another drink. It just rolls on out and lives its life. So I have a theory about this. Attacks are automated. This is pretty much known. All these web-based attacks are all automated scripts that are just going through, scanning, trying new exploits. But if attacks are automated, that means there's code involved, and there's definitely lead time for the attack code to be updated. Now, when the attack code gets updated, that's when puberty hits, and that's when shit hits the fan. If you haven't secured your site by that time, you're going to get compromised now. As well as note that what happens during that puberty stage, why it gets so explosive, is that a compromised site adds a new node to their botnet. So your compromised site will then participate in compromising other websites. This creates an exponential growth. And it'll vary a little bit, but it'll be certainly an exponential growth in the size of the botnet, in the size of the number of attacks per day. So I'm going to talk again now about a new exploit. Who here knows about the PHP CGI remote code execution exploit? This was a really cool one. Basically, it allowed arbitrary code execution. It also allowed source code disclosure, as well as a denial service. You pretty much do anything you wanted if the host that you're running on was running PHP in CGI mode and didn't have this patch applied. This was released in May 2012, so it's much more sooner. Our staff was actually notified before May because this was actually identified on our network, and we applied a patch to PHP as well as a virtual patch in mod security so I can do some logging, and this was all rolled out well before the 0-day release, which gives me really good graphs. So this is that same graph I just showed you, Zencart, E107, and TimThumb. And now this is the PHP CGI vulnerability. Here's where it was discovered. There were almost no attacks when it was discovered. There's a little trickle right beforehand, and I think actually those are just false positives. But right there, right that day, this day is the day it was released. And I guess in the infamous words of MC, I think it was Frontalot on the very first day, it's already too late, is certainly true in this case. The day it was released, because of this complexity of this attack was so simple, everybody and their mom, and I don't even know, but everybody was doing this attack. Within a week, there were 2 million, this spike here is 2 million attacks on one day of just people scanning, trying to find out how many hosts are compromisable for this type of attack. It was averaging out exactly what the WordPress TimThumb was, and then basically went on there. What's interesting though is, just like with WordPress, there was a spike, a lull, and a spike again. And the same thing happened. It's also almost the exact same time, about 2 months difference between this spike and this spike, as well as over there, those two spikes of red. And that's very interesting because, again, that it kind of shows the same lead time to attack, same lead time to update their code, to do more initiating attacks. And when I inspect the individual log lines of these, the first grouping of attacks, here, especially for the PHP CGI one, that's a lot of discovery. That's just people interested and curious. Actually, there was 1 million hits from one host on one day. I found that very interesting because I'm like, why would this one guy do this? And I presume it was simply a security researcher looking into things, trying to find out what percentage of the internet is affected. But then 2 months later, it completely changes. It's a very variety of hosts trying the same exploit, and they're all trying the same thing. And so those are basically probably the malicious people at that point in time. So, and overlaying my simple ideology of there's an infancy spike, there's a puberty spike. The puberty spike is going to be worse, longer, more intense. And it hasn't hit maturity yet, unfortunately, but I'll probably have more information the next time I give this talk. So that's the basic idea about how bad things really are, how quickly an exploit gets to be effective and can be a problem. So we take these logs. I don't just make pretty graphs with them. I actually do things with them every day. I have an automated system that sends notifications to the ISP's abuse desk whenever we get too many attacks from a certain IP address. About 90 or so ISPs are notified on any given day, and the vast majority of them are non-responsive. I'm not knocking on them for not being responsive. I understand that job is very difficult and very trying and very busy. I do that job as well. But there's something to be said about the fact that I know that most of them are not being responsive, and most of them are likely not capable of taking care of the action, and they're not doing the right thing because the same IPs are coming up again and again and again. And it's a very complex talk. That's a talk in itself, doing abuse test stuff. But back to what's interesting is 20% of those attack sources appear to be home ISPs or business ISPs, while 80% appear to be hosting or data center IP addresses ranges. This also makes sense because in the idea that the compromised websites are then attacking other websites, it's pretty much the world that it is. And the botnet gets very large very quickly and becomes very bad. So I'll talk a little bit about incident response. I kind of feel as if it's obligatory. Response breakdown. If you have a compromised site, it's pretty easy. It's do immediate mitigation. You just want to put out the fire. You want to monitor for changes, and you want to review what's going on, what caused the issue in the first place. and then do a long-term fix. Might include correcting your business policy and or securing your code, configurations, applying better virtual patches, etc., so forth. The standard approach is this circle. I feel everybody needs to have a circle or some sort of graph that shows you representation about how you should be doing your job. Ooh. And I say, oh, there's a better graph. So it's basically monitoring and always evaluate and update. Don't ever presume that your site or your code or your systems are all functioning right. Just always presume that they're going to get compromised. Look into them. It doesn't have to be every day. Just look into it once a quarter. Look to see what's going on, see if there's anything that is out of the ordinary. So now more interesting, though, is I'll do some auditing nitty-gritty. This is what I see majority of our customers who have compromised sites that have really bad issues when it gets really nasty. This is what they weren't doing, and this is what they need to do to make sure that this problem never becomes a big issue again. This starts off with file monitoring, as well as reviewing some logs via various methods. And even I'll give you guys some information about what utilities and what scripts I use to do malware detection by hand. It's very easy, and hopefully I have more stuff to go on for that. File system monitoring is actually also very easy. It should be part of your backups because you don't want to waste all your file I/O on your main server. Be it even if you run your own dedicated server for even one website or whatever, you don't want to. If you're peaked out on your file I/O or your CPU or your resources, you shouldn't be doing your file system monitoring on that system because it's going to always cause an issue. And you don't want to have file system monitoring cause an outage on your main server. Instead, use your backup server. Like, you should have backups. I should preface this with the fact that you should already have backups and you should have a dedicated backup server. That server is probably sitting idle 90% of the time, and you have all the resources on there, a CPU, a system, some memory. You can do file comparisons based on your newest backup to your last backup, and amazingly enough, rsync has this built in already. So if you're using rsync as your backup system, you already have your solution there. You just need to take that output and have somebody review it. There's more nuances to this, but it at least gets you 90% of the way there. If that doesn't fit for you, you can also use iNotify, which is a kernel-level file system monitoring hook, basically like library and hook system, as well as Tripwire, which is mostly open or mostly free, but you can pay for their premium service. It works pretty well. It runs as a daemon or a service. You can also do it yourself. I don't recommend doing it yourself. It sounds like the easiest thing in the world of doing MD5s against all your files and doing the comparison on your own. But the reality is you're just going to be wasting resources because things already exist to do backups for or file system monitoring for you. So when a site's compromised, this is pretty much the first thing I do, and I always find like typically what's going on, what's broken, whatnot. So this is an example of like a backdoor found on a website. The area in red is a timestamp. You then just grep for that timestamp in your website's access logs, and you'll most likely find something interesting like a post request to this plugin page called hello.php. That is most likely the first step. Hello.php in this case will most likely be a backdoor. Most of the time you're not going to be this lucky and catch it soon enough so that you can actually do this inspection because your access logs may rotate out, but that's part of the detection process is being able to know your site's compromised sooner than later. If that doesn't work, like let's say it was too late or you couldn't find, you don't know where the initial backdoor is and you're just kind of digging around, use awk and sort in a very interesting way here. You just basically print out the line of the request. Basically, it's number 7 here for awk print 7 is the column in the access logs, which is the file that's being requested. Pipe it through unique sort, which seems redundant, but it works magic. It will give you a list of the files being requested on your website, and basically the first number here is the number of times they've been requested. What's interesting about this is actually my site's access logs. You can see I get only about 200 hits a day, but a lot of them are to phpMyAdmin for some reason. I don't have phpMyAdmin installed, but this would show me that, well, there's people trying attempts to hit phpMyAdmin, most likely an exploit, most likely a bot trying to scan for a known vulnerability in phpMyAdmin. So if you even have no success with that, just use find. It's amazing. Find will find things on your system. This is part of the this is my little special script that works magic and wonders, and it's so simple because it literally is. It's not even a one-liner; it's one command, but it uses find in a very interesting way. So you can use find. You know how to use find. It's just find the path, and then you give it some arguments. The difference is you're going to want to run man find, so you can read the manual page, and you're going to find out that find has a lot of options, one of them being exec. So exec calls another basically command and takes a response and runs that command against the file, takes a response from that, and gives it a yes or a no whether or not it's a match. In this case, I'm finding everything in this path, and then I'm executing grep for this fingerprint. Fingerprint would be a variable you set earlier. But if grep finds that fingerprint, it reports back to find positive, and then find outputs the name of that file. In this case, it seems kind of redundant because you can just run grep against all your files and then parse that out yourself, but I'll get into how this is really powerful very shortly. You can use generic fingerprints. These are what we see, and I'm going to go at the end. I'm going to show you a lot of backdoors, not the malicious backdoors, web-based backdoors, web shells, what they're called. But these are just some generic ones: eval, preg replace, exec, assert. Anybody else know any PHP commands, like functions that actually execute code? There's like 24 of them. It's fairly annoying, but there's a lot of them. So find them all. You can look for some generic ones and find out either a compromised web shell, or some piece of your code that is really stupid because it's running eval for some reason because it can't do whatever functionality it needs to do in PHP itself. And you can also use fingerprints for known backdoors. This is a much better way to do it, but you have to have a lot of backdoors, a good sample set. I'll also show you how to gather your own backdoors. I should stop saying backdoors. This guy. So let's get into how find gets really powerful. This is a very interesting way to run it. This is the same example I gave earlier. Find and then give it a path. You can do exec, grep, fingerprint. You can also do name, file size, etc., so forth, but I'm not worried about that here. You can chain exec commands together. So when you run find and then exec grep for that fingerprint, grep reports back to find this file is confirmed it has this fingerprint in it. You can then run another exec immediately afterwards, and find will only run this exec on the files that match the previous rule. So exec grep, this file has this malicious code in it. Also run this command, change mod 0. Remove the permissions for the file so it's no longer a threat to the website. That's pretty much the magic sauce there, is that it works, it's fast because it's using find, a pre-existing tool, and it will disable any known backdoors. The problem is it will also disable non-backdoors if your fingerprint is not good enough. What I also see is a lot of backdoors are injected on the first line, the last line, or a random line in the middle of the file. So you have to do another option. Using the same tool, exec find to exec and grep for that fingerprint, use sed to remove just one line from that file, or just the matched fingerprint from that file. So exec sed, and then do a search and replace for the fingerprint, replace it with nothing. I do apologize, these are kind of somewhat Unix complex advanced commands, but you should also all learn these if you don't know them already. Find, exec, grep, awk, sed. Yeah, they're very important. But so anyways, it'll basically search out for that fingerprint and remove it from just that one fingerprint from the file. If you have an infected site that every single page on your site has some HTML entity added to the bottom of it that's doing some nasty shit, and you didn't have backups and you're pretty much screwed already, this will save your ass. This will run through, and you can give it the fingerprint of the malicious code, and it will remove all the malicious code from the site. So who here knows what the attacker's motivating factor is? Nobody? Who here, what's your motivating factor? Let's, money. Yes, you're right. There's other options, but the vast majority of what I see on our network of automated attacks that are just grinding away at 2-year-old exploits in web software is money. They are trying to do things that earn them money, and that's kind of annoying because that's not really what hackers do. Like, hackers are interested in finding and breaking in the exploration. Assholes are trying to use that to make money off of it. And when yeah. But so if you find an exploit, if you're that type of person that likes to find the exploits and you're not the asshole, yeah, there's bounty programs out there, Facebook, PayPal, they all have them. You actually can earn money for finding exploits. If you do responsible disclosure, if you do it enough, you're actually going to get a name for yourself, and everybody will know that you're the type of person that's trustable, reputable, and you'll get a nice paying job. Don't become a criminal, because frankly, the criminal avenue is not well paying. They're not good people to work with, and the majority of the stuff that I see, if anybody you are criminals, you're going to come up here and punch me afterwards, your code sucks. I'm sorry. A lot of the criminal code is not that good. It's very interesting. It's fun. It makes my job easy, but The majority of what I see in these, I should say, with these automated attacks, it's not state-sponsored stuff. It's not the really high-end espionage. This is just the automated attacks and just this grind. And I imagine that these programmers are basically have this guy, like this crazy burly guy over them, like yelling at them to program better PHP. But so I'm going to go from zero to explain how O-Day to Payday works. This is what I see on our network. They basically install the backdoor, and then they sell access to the backdoor on the black market. The people they're selling access to are trying to run phishing scams, send spam, do some black hat SEO, steal traffic from the site and send it to their own site, or just install more backdoors because, frankly, that's what they do. What's interesting, too, is I didn't mention it earlier, is that a lot of these backdoors, when they're installed, the attacker will take no action for a short period of time. This may be weeks, it may be months. This is actually fairly smart of them, I should say. That they know that if they take no action for a short period of time, the access logs or any logs that will identify the initial point of intrusion will be overwritten, basically rotated out, and that kind of hides their tracks. If you did use the find that I used before, that's how you basically find all those malicious backdoors anyways and still get through. So, does anybody here not know what phishing is? All right, good. I'm going to send you all emails to test you later. Spam, everybody knows spam. Everybody gets spam. Black Hat SEO, this is a newish thing in the last 10 years because of SEO services and because of the popularity of Google, Bing, everything. People basically hide links on websites. You probably have all seen a site with hidden links at the bottom of it. They all kind of match the background, or they're a hidden CSS div. Basically, they take their intention is they're trying to get more link backs to their site to increase their SEO ranking. What's funny is Google and Bing and every major reputable search engine has figured this out already, so it actually dings them for doing this. What the inverse, completely silly mode of this all is now people use Black Hat SEO against their competitors to try to ruin their competitor's search engine thing. And so it's like this weird back and forth where they might be helping their competitors accidentally, or they're trying to hurt them, and it actually ends up being a very weird case. And I won't get into the specifics on how weird and obscure that ends up being. A little bit on traffic theft. This is a method to take the legitimate visitor to the website and send it to another malicious website. This is kind of Black Hat SEO-ish. It's kind of like affiliate marketing-esque. They're basically trying to send you to some site that will try to sell you something, or just send you to a site because you're one extra number on some traffic board where they're saying they'll sell per view or something like that. This is very similar to the flashback Trojan, and I'll go into that in a bit. And also finally those backdoors. Obviously, you're selling things on the black market, and these people already know they want access to backdoors. The backdoor code is pretty well out there. You can just go to phpshells.net, or I don't know, I just made that up, but it probably exists. There's a lot of sites out there that just have huge indexes of example PHP backdoors, and you just go download that. You go get access to some other person's backdoor network, and you tell that backdoor network to upload your own file. Turns out you're just uploading your own backdoor, so you have free access in the future. This makes sense because why not steal from the people who are stealing? A little bit on traffic theft. In Q1 this year, we actually saw a huge influx. It was very interesting to see what happened. Suddenly, all of our customer sites or not all, I shouldn't say that. An alarming number of sites were shown identity. Basically, were shown that were compromised with this this method of traffic theft, where they were trying to redirect the visitors to another site. And I was like, wow, this is very interesting. This is kind of newish. And it was kind of after the Tim Thumb thing, so I wouldn't blame it. I wouldn't correlate because I have no hard data, but it seems like coincidental that the timing is about the same. Actions were taken, data was recorded, and I'll show you here. So here's an example about the infections that we were seeing. It was an HE access infection, and it would add lines like this error document 404 to congrazi.ru, and the URLs didn't matter. There were a lot of them. Or they would add this rewrite condition that basically said if the referrer was Google, Yahoo, etc., if it was a search engine, send the rewrite rule to go back to congrazi.ru. This was the malicious site. It would attempt to redirect the visitors and do things like, example from earlier, is it would try to install the flashback Trojan horse on OS X systems. That was actually a fairly serious problem, which is now cleared up. But this was one of the methods they used for distributing their malware onto systems. I should also add that the code for this was on the Congrassi site was very smart. It knew what type of browser you were hitting it with and would send you specialized payloads. So if you're hitting with OS 10, it would try flashback. If it was a Windows system, it would try various known exploits for those Windows systems. I didn't note anything for Linux or iOS or mobile, but I'm certain that there plausibly could have been. So I basically grabbed those rules over here. I did a quick grab of every one of our customers. I basically scanned our entire network for anything like this. Using basically the find script that I showed you earlier, I grabbed every one of these and I cleaned them up for the customers. I notified the customers, and basically I grabbed that URL and I saved it to a file. So I got a list of all the malicious URLs being used. There were about 1,000 unique domains found using this method. So I'm going to break it down. The vast majority of them, I scanned all of them against sitecheck.com. 2% were safe. About 40% were unknown, which I'm going to presume also means they were just not known to be malicious yet. And the majority were low-risk or known malicious sites. This shows that this was very good information that I had on this list of URLs. The top-level domains for these were, I would say no surprise, but it's coincidental. It's just simply that .ru, then .com, then .info. This isn't a knock on .ru. It's simply that I can identify that the people using this were either trying to mimic or they had a good registrar that .ru domains were really cheap. So I looked up the registrars, and surprise, reg.ru was half of them. Then it was Directy and various other ones in GoDaddy. These cases, again, it's no surprise. It's .ru, reg.ru. Chances are they got a deal or they scammed their system there, and they registered a crap ton of domains. The IP addresses that these domains resolved to didn't show a lot of information. There were various. A third of them were random, and then 208.87.3.5 was 22%, and then so on and so forth. There wasn't a lot of good information in that. Sorry. So any questions yet? Yeah. No. A lot of that stats, I mean, I could pull it now, but it would be kind of too late. But the specific name servers, no, I can't recall offhand. It would probably be improper for me to try to call offhand how many different name servers were used for those.
I understand that name servers are the bottom of a lot of tabs.
Very plausibly. Doing the name servers, we're going to have to be good. But there's so many free ones. It would be a good metric to know exactly how many they use for those types of attacks. But sorry, I can look it up now. It's just probably not going to be useful about 6 months later. So I'm going to go into backdoor. Basically, I'm going to audit. I'm going to show you guys the evolution of backdoors that the malicious people use. This is pretty fun stuff. It's pretty neat. I'm going to presume you know a little bit of PHP or at least can read code. So this is the method I use for collection. This is what's really interesting is I basically scan compromised sites for malicious files and grab those. And then I looked at attack logs, and the attack logs actually give you locations of backdoors, and I basically scanned those. In total, I have 14, 15, 2,000, or 1,500 or 2,000 or so backdoors that are unique. If anybody's interested in having this list, let me know. You'll just have to verify yourself as a researcher, not as a jackass. So getting the backdoors from the attack logs was really interesting because the Tim Thumb attack, basically like I mentioned earlier, the Tim Thumb attack, you gave it a URL and it would download that URL and dump it into the cache directory. It turns out that attack gave you a big, huge exact identifier of where the backdoor was. So I would run through our attack logs every day, or what was it, 50 or 70,000 attacks against Tim Thumb per day, and then go download all the backdoors that they were using. So yeah, you basically get the URL, download it, and then you can review it, and it's like, oh yeah, that's a R57 PHP shell. I think that's exactly what that one was. What's funny is they actually even give you version numbers, and some of the attacks I was seeing were using versions from 2009. I don't know why. The PHP CGI vulnerability had a similar method that I could pull attacks from, or basically pull backdoors from. It would do this -D and then this long string of various PHP-specific commands, and then eventually you say prepend this file, which is add this file to the file being executed, and it would tell the file location, which could be a URL, which is kind of annoying. But anyway, so that's how the backdoor gets injected. So download it. Again, R57 shell. It's one of the most popular ones. Again, but in this case, it was using 1.666. They're only about 6 to 8 months apart, these vulnerabilities, yet they use completely different backdoors. these backdoor versions. So I'll go into exactly how these backdoors work. So this is dead simple. Anybody here can't read that? Good. It evals a post payload. And then they get a little bit more complicated. They'll use a MD5 cookie, or basically a value of a cookie, and do some authentication before they allow somebody to execute code, so nobody can just run around executing code on their backdoor. There's also some backdoors that are very well documented. These are funny because they act like they're very much intent on being good code and having good documentation, explaining to people who may not understand how they work, how to use them, like create password, use password, true and false. Default, like, okay. I should also note that decompiling these passwords and reading them is very, very useful because you can do things like you can find the passwords used in the previous case. You can find the MD5 value right here. And if you can crack this hash, then you can do a specialized rule that will disable this backdoor against the entire network, as well as identify compromised websites on your network. So then it gets a little bit more complicated. Eval base64 decode, and then this really long string of base64 encoded string. What will happen here is it basically decodes the string and then evaluates the thing. When it's deobfuscated, this is my favorite way to handle these, is use sed again. I highly recommend you guys all know how to use sed. There's many other ways. In fact, I searched online. I think I saw on rnetsec, somebody was linking to various other methods, tools, and websites that you can just dump this code in it, and it'll scan through it. This, I basically say switch out eval with print, and then execute the code, and it basically eventually will output something that looks like this. And effectively, what's interesting, though, is that this is the same backdoor as we saw previously. It will be R57. Every time we run these deobfuscators, it will always end up being the same initial backdoor. So I know that's the same people running the same, basically, botnets, because that's how they control it. And then it gets a little interesting. I mean, they find out base64 decoded strings are easy to detect. So they base64 encode a GZ string, basically gunzip or gzip, and then they run eval against it. Again, and this one was interesting because they actually set the code in a variable instead of setting it as the exact argument. I give this guy a gold star because he basically just added an extra little level. Rot 13. It's silly, but honestly, it will correct things. It'll defeat the pre-existing signatures. Yeah. Of course, I'll be very interested to find anybody who has a valid use for these four functions together. So, at that point in time, like everything, any sort of signature they use is easily detected. This is what I call regex revenge. It uses Perl regular expression. It basically does a search and replace. In this example, for some reason, PHP decided that doing a search and replace, you might want to just execute the code that you're basically the string that you're searching and replacing as code. For some reason, so they gave preg replace the -e flag, which says evaluate or execute whatever the code matched is. In this case, $* means match anything in the next argument, or match everything in the next argument and execute it, which is exactly an very easy way to just execute code. Up there, the -X6567 or 76, that's hex. That's just hex for eval. And then it looks exactly like, when it's all decoded, it looks exactly like this. So they're just reusing the same backdoors over and over again. They're doing different methods, and all in hopes that they'll get around detection methods. And the variables as functions, this is very interesting. So who here knows what this is doing? Anybody? Yeah?
Same thing as the other one.
Yeah, that's great. This one's a little bit different. But what happens is, once again, PHP has a very interesting way of handling things, and they decided that they want the developer to be able to assign the name of a function to a variable. You can then call that function from using the variable, using an @ sign, and then to basically execute whatever the value of that variable is as the function. So in this case, you can see the AS, this value AS is here, there's an E, and there's an R and a T, and there's a B and a 64. That basically eventually adds up to being assert base64 decode, which is pretty much the same thing, but they're using assert now instead of eval. But once again, it's the exact same thing, and because PHP allows you to assign the value of a function to a string and then execute the string, it's hard to explain that, but execute the string as the function that its value is, it's pretty messed up. And then this is a really good one. I'll give a beer to anybody who knows what this is doing, except for Stephen Burler. Anybody? Anybody want to take a guess? And don't say the same thing as before. It's not. This one's actually very different. The method of obfuscation here is probably the most advanced that I've seen. It uses bitwise operators. It compares these two strings using an OR, and assigns it to that. Then it compares these with ANDs, and assigns it to this one. In the end, it ends up actually looking very similar to this one, where they use an @ sign and they execute the variable at the function value of the variable. And it ends up being the same thing, eval, basic C4 code. But they use bitwise operators, and bitwise operators pretty much give you an almost infinite number of comparable strings that will be very difficult to detect and remove. Which adds to my conclusion of basically, I can show you, I've shown you right here, attackers are evolving their code every day. Most of the time it's very trivial changes that they make, but they're functional for fingerprint matching, to deter fingerprint matching against a compromised website. Fingerprints are completely untrustworthy. Seriously, monitor your file system. You should be doing backups. Put it on your backup server to monitor your file system, and you're going to have a much better time. So I would like to thank everybody here at B-Sides, as well as OWASP, who I've given the conference this talk at, as well as Trustway for pretty much their work with mod security. Without that, I wouldn't have any of the data here. DreamHost and our customers, as well as every right hat security researcher out there. And here are some links for further reading. Mika Panian, I just mangled his name. That's great. He does a lot of great TED Talks about the motivating factors behind these attacks. The Spider Labs blog is fantastic to find out motivating factors as well as techniques the attackers are using. And I go ramble every once in a while on the DreamHost blog about security. If you want to follow up, here's my email and my Twitter. Go harass me, tell me I'm an idiot, or come find me. If you're going to punch me, just give me fair warning. But thank you. Any questions? Should I ask? Awesome, I got swag.